Hello there, welcome to this problem solving session for math and logical reasoning for competitions. In this video, I'll show you how to solve problems where there are few shapes drawn on a paper and some objects are inside one shape but outside another. We have to count objects that meet certain conditions like this inside this shape and inside the other shape, or inside this shape but outside the other shape, and so on. So there can be different types of conditions, and we have to find out how we can meet all those conditions and find the count of objects. We will call them intersecting and non-intersecting areas. So that's something that we will um, understand in this video, and then we can find out. Then we'll see how easy these problems become when we understand the concept of those intersecting spaces. Let's jump into a problem and see what is overlap, what is an intersection and non-intersection. So, in the first problem, Blake was collecting star shaped cutouts from the floor where cutouts were inside the rectangle but outside the circle. How many shapes will Blake be able to collect? So, the condition here is that we can see a lot of shaped cutouts are spread all over here, and all we have to do is to find out or count the number of shapes where it is inside the rectangle but outside the circle. So let's first underline what is asked. So inside the rectangle and but outside the circle. So this is the condition that we have. So now let's understand what is the intersecting part. So this is the circle and this is the rectangle. So where is the intersection between the circle and the rectangle? So you can see if I highlight using this color. So this is the part which is common, which is inside the circle as well as inside the rectangle. So this is the part which is inside the circle, both inside the circle and the rectangle. This is the part, the lower part is, this is the part which is inside the rectangle but outside the circle. So we have been asked like inside the rectangle but outside the circle. So this is the non-intersecting part between circle and rectangle. So this is the non-intersecting. Remember, if it is outside one shape and inside another, that's called the non-intersecting part. And if we have inside both circle and rectangle, then it's called the intersecting part. So that's, if you keep that in mind, it becomes very simple. So in this case, we are talking about the non-intersecting part. So how many star-shaped cutouts are there? One, two, three, four, five, six, seven, 8, and 9. It's as simple as just counting them once you understand what is non-intersecting part. Again, whatever is inside one shape and outside another, that becomes the non-intersecting part. But now we have to see which shape it is inside. So it is inside rectangle but outside circle. So this becomes the non-intersecting part. If we were asked inside circle but outside rectangle, so then anything that is outside this will be the non-intersecting part. So to define, to just to be uh, a little more clear about this, so let's draw this. Here is a circle, here is a rectangle. Okay, so now let's say we have something that is inside the rectangle and outside the circle. So if that's the case, then we will have inside the rectangle and outside the circle. So this is the part. But let's say someone asks us, so this is the non-intersecting part inside the rectangle. Someone asks us inside the circle but outside the rectangle. So this is the non-intersecting part and it is inside the circle. Someone asks inside this rectangle and inside the circle. So this becomes the intersecting part. So careful about the term. So in intersecting part is both inside circle and a rectangle. So this becomes the intersecting part, and we have to count in this area only. So now going to the problem, inside the rectangle but outside the circle. So that is our square here. I can also mark with a different color. So this is the one. So it's going yellow. Okay, so now it's in yellow. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So our answer is 9. So it's pretty simple when you uh, find out the concept of intersecting and non-intersecting places. So let's jump to the second part of this problem, or a different problem, which is slightly different than this. So here I'll bring the next question, and I'd suggest that you pause this video here and try this yourself, and then come back and see if your answer if you are able to answer this correctly. That will give you a very good understanding and confidence about solving this type of problems. So I'll pause here for a sec, and you can pause the video here and come back. Okay, welcome back. So hope you were able to solve this yourself. Now I'll explain how to solve this kind of problems. So let's understand this problem first. Charlie was collecting the star-shaped cutouts from the floor, where the cutouts were inside the circle and also inside the rectangle. How many shapes will Charlie be able to collect? So as we discussed, this question asks about inside the rectangle and also inside the circle. So it brings us to our original idea of intersecting spaces. So inside the circle and inside the rectangle is the intersecting part. Last time we were finding in the non-intersecting part of the in the triangle, in the rectangle, sorry. But this time we are finding in the intersecting part. So now we just have to highlight the intersecting part, and then we can then we'll understand how many are there. So let me draw the intersecting part. So intersecting part here is this. So inside, remember, it's inside the circle and also inside the rectangle. So this is the condition. So for that, we have, we'll mark the intersecting part just like in the other diagram where I shaded it. So this is the intersecting part, and all we have to do is, maybe my drawing is not perfect here, but you understand what is the intersecting part. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 of the star-shaped cutouts in this intersecting part. So how many shapes will Charlie be able to collect? So the answer is 8. So that is that. Then I'll go to a similar problem again, and I'd suggest you take another pause here and try to solve this problem, attempt this problem yourself, and see if you can solve it. Um, so I'll pause for a second. Okay, welcome back. So here in this problem, Andre was collecting star-shaped cutouts from the floor, where the cutouts were inside the circle and also inside the rectangle and the triangle. How many shapes will Charlie be able to collect? So this is a little more complex problem where we are talking about three shapes, not just two. But this it's the same idea. So I'll just explain with the same concept that we discussed so far. So we have a circle, we have a rectangle, excuse me. So this is the rectangle, and we have also a triangle. So there's a triangle here. So we have this kind of a triangle. So now if we are to find the intersecting part, we'll have something that is inside circle, inside rectangle, and inside the triangle. All three have to be there. It has to be inside all of three. So this will be the intersecting part. The small left out places here, these are inside the circle, inside the triangle, but outside the rectangle. So I'll mark them in yellow so that you understand what is that. So this is inside the circle and triangle, but outside the rectangle. And if I mark with green, so this is inside the circle, but outside the rectangle and triangle. So this is purely non-intersecting. So this is partially intersecting, this yellow part. The green is completely non-intersecting. These are also non-intersecting because these are only in one shape and not the others. So the pure intersection between all these three is the red part. So that's what we have to do here. We have to find the number of stars in the red part. And we have only four there. If you count one, so I'll mark them in a different color with a line so that you understand which part we are talking about, just like in that other image. So here is the intersecting part that we just highlighted in that image. So I'll just border it here, and this is the one. So this is the part that we are talking about. So there are four star shaped cutouts in the intersecting part of all three shapes, the circle, the rectangle, and the triangle. And so our answer is 4. So A4 is the answer. So that's how you solve the problems related to intersections or between different shapes. And this is also called set theory, which you will understand when you are in an advanced grade. But for now, just understand that we have to find out the intersecting part between the different shapes, and that's how we can get the number of objects that is asked for. So thank you for watching. Let me know in the comments if you have any questions or if you have any doubts on this topic or any other topic for that matter. And see you in the next video.